here's the issue. We, up until this point, have only ever talked about real numbers, all right? You kind of haven't even known that such things as non-real numbers even exist. But here's where the issue arises. Is there any number that you could plug in for x that would ever equal -1?
No real number.
Right? Because when you square a number, it's always positive. So usually when we get something like this, we say no solution. When we really should say no real solution, because there really is a non-real solution, all right? So this great mathematician named René Descartes, who I think his picture is right over there on the podium. It looks like Descartes, but it's Descartes. He proposed we define the letter I, right? And I always write I like this because otherwise it's easily mistaken for a 1. Maybe you think that's a J. I don't know. I think you should write I with the tail on it. He proposed, let's say that I squared equals -1. I squared equals -1. And if that's true, if you wanted to solve for I, you could take the square root of both sides. And if you did that, then I equals the square root of -1. These are super, super important definitions. So I is not a letter anymore to us. It's kind of like I is the square root of -1. And we use the letter I to represent the square root of -1.
You is. Get it?
So we say I is the imaginary unit. And they just use I think, because imaginary starts with I, right?
I get it.
So there's a whole lot of stuff we can do with imaginary numbers, and it's really, really important when we get to this theorem called the fundamental theorem of algebra. But we're a long ways away from that. So we have to just get comfortable using I and simplifying I before we can get to the equation stuff. So that's what we're going to spend the next couple days on. So I, and it's fun to teach I because you get to say things like I is this, right? That's fun. So this brings us to a new set of numbers called the complex number system. And this is it. I'm not holding out on you. There are no other numbers that we deal with that are not in this set of numbers. So the set of complex numbers can always be written. Drew, quit talking. This is an important day for people. Not for you, because you know it already, but it's an important day for other people. Every complex number can be written in the form a plus bi, where a is the real part, the real number, and the bi part is the imaginary number. So if I drew a little picture here, this would be the whole set of complex numbers. You got your real numbers over here. I'm going to go on here.
Yeah.
You have your real numbers here. That's your integers, your rational numbers, your irrational numbers, your whole numbers. And then over here we have your imaginary numbers. And if you put all the real numbers and all the imaginary numbers together, it makes the set of complex numbers. So we're just going to practice dealing with them, okay? The big thing to remember is that I squared equals -1, which means that we can actually simplify things out, and we should never have anything more than I left in our problem. That's kind of the big goal today. All right? It also means we can simplify things that our calculator says error to, because on my calculators, if you take the square root of a negative number, it won't do it. But with imaginary numbers, you can do it, all right? There are some scientific calculators that will do imaginary numbers, and if you have one of those, I probably am not going to let you use it on a test, just FYI.
So how we check it?
I will tell you, okay? But you shouldn't even try to find it, because you don't need to know it, Thomas. If it does it, you should ignore it, because it's not going to help you on the test, right? So I'm going to show some work on these, and then maybe you'll find a shortcut. That's okay. But square roots, these are should be all nice ones, but maybe not. In Algebra 1, you worked on simplifying square roots when you did the quadratic formula. But like the square root of 100, that's a perfect square, right? But if you type in the square root of negative 100, it's going to say, what's it say, Sydney? Error, domain error, non-real resultant.
Math error.
Because the calculator doesn't know about imaginary numbers. But we could rewrite this. Could I separate this as the square root of 100 times the square root of negative 1? Is that the same as the square root of negative 100? So if you break it up as the real part and the imaginary part, what is the square root of 100? 10. What is the square root of negative 1? I. So we say the square root of negative 100 is 10i. 10i. So if I did the same thing with negative 169, also my calculator says error. But what if I broke it up as the square root of 169 and the square root of negative 1? Do you know what the square root of 169 is? 13. You could do it on your calculator. It works out nicely. And what's the square root of negative 1? I. 13i. What about 28? Is 28 a perfect square? No. So do you remember in Algebra 1, or maybe some of you in geometry, we did this in geometry as well, we don't want the decimal, right? If you forget about the negative and you just wrote the square root of 28 in your calculator, again, some calculators are fancy and they'll give you the radicals. I don't like those. I don't want the decimal. I want the exact answer. So that's where, first of all, I'm going to pull out the negative 1. I'm going to pull out the I. I like to say that because it's fun to say I'm going to pull the I out. So let's just pull the I out. I feel like I get way more joy out of this than you do. Then I have left 28. You want to think of two numbers that multiply to give you 28, one of them being a perfect square, because if you can pull a perfect square out, you can simplify it. So if you remember, you could write this as the square root of 4 times the square root of 7. And can I take the square root of 4? It's 2. Can I take the square root of 7? No, it's a gross irrational number. So we want to leave it exact. The extra part is I have this square root of negative 1. So I'm going to write that as 2i, and then I'm going to leave the square root underneath it. I always put the square root at the end if there's one left, because I think if you write this, sometimes people are a little messy, and it looks like the i's under the square root, and it shouldn't be under the square root. So I always write the I in front of the square root. Today, I don't think I gave you any that you had to do that. I think I gave you all nice ones that worked out, I think. No. We're going to do one more step, I think. I'm really bummed out. I wanted to get to this other thing because I'm not going to be here to do it. But this is it. We'll do this slide and then we'll stop. So you can also do the same thing with I that you do with x's. Like I is not x. I is a number. X is a variable. But you can kind of treat it like that. And remember that I squared equals negative 1. I know. So first of all, if I multiply negative 2i times 7i, what do you think I would get? What do you think I should do when you just multiply the numbers and you multiply the i's, just like if it was x, negative 2x times 7x. So negative 2 times 7 is negative 14, and I times I is I squared. So you can treat it like x, but then you have to remember that I squared is really a number. So if this was negative 14x squared, we have to just leave it because we don't know what x is. But do we know what I squared is? So this is really negative 14 times negative 1, which is just 14, which means we can take an imaginary number times an imaginary number and get a real number. It's exciting, right?
No, I'm geometry.
do number 5.
I already have the answer. Negative 14. That squared is 14.
Yes, because I squared is negative 1, so I'm just replacing I squared with negative 1.
I squared is
So negative 14 times negative 1 is 14.
So basically, if it's I squared, it's automatically going to be whatever.
It's going to be like the opposite, right? Because it's a negative 1. Yes.
mistakes. 2 i's equals 7.
Tyler, stop using your calculator. So again, and people are gonna not show work, and I'm okay with that. But remember that I squared equals negative 1. So when you have a negative number times I squared, it's turning it just into the positive. So we get positive 6.
Alright, this one's well, I just got 14. Square root of 14.
Why did you get the square root of 14? What should you do with that 12 and that 2? Should you be adding those?
Hey, you can multiply them together.
So why did you multiply them together and get 14?
Oh, never mind.
Right? So Alex is on the right track. He said he got 14 here, but what he should have got is if I have a square root times a square root, can I just multiply those together?
Sorry, future me, I didn't get it.
And I would get the square root of negative 12 times negative 2, which is positive 24. So again, first of all, notice imaginary number multiplied together equals real number. It's like Pinocchio turning into a real boy.
Pinocchio, right? Man, you were just having fun today, aren't you?
I like imaginary numbers. Do I want you, Thomas, to type this in your calculator and write that decimal down that you just did? No!
I didn't write down decimal.
Okay. I want you to simplify it. So, can you think of 2 numbers and multiply to give you 24? One of them is a perfect square.
6.
And what's the square root of 4? Do I want you to type the square root of 6 in your calculator? No. I want exact answers.
1, 2. That is exact.
Absolutely. Wait, why is it an I?
Because we made it a positive number, right? So there's no I if it's positive.
Oh, yeah.
So then, why?
Like, you could make it a lot uglier, but yes, and still get the right answer. So really quick, the only thing I'm going to say, because there's one part I really, really wanted to get to, and I'm
No
not.
homework.
What if I asked you what I to the third was? What would you say?
That
I
would
would
be
say that that's a mistake and that shouldn't exist.
I squared.
Oh, so Sydney said, you might want to write this down, kids. Sydney said that's the same as I squared times I. Is that true? Could you rewrite I?
It's the same as negative 1 times I.
So it's the same as negative 1 times I, which is just negative I.
Ooh.
So you can only make I go away as if it's I squared, which is the square root of negative 1, but we always leave that as I. I is the square root of negative
So
1.
if you multiply it by both sides,
But it's the negative of the square root of negative 1. Okay.
I like imaginary numbers. I'm gonna go speak to myself in a few
Okay, so I did not get to all of this, which means that you don't have to do all of this yet, but do not scribble it out because you're going to have to do it all on Monday. Yes? So, on your homework for this, I want you to try 1 through 5. Number 5 you might have an I to the third on number 5, and so we'll see. And then on Monday, I'm going to leave you a video of how to do like I to the 42nd power, and how to add and subtract with them as well. Okay? So 1 through 5. Bring it back on Monday. Bring your notes back on Monday, right? I have a few extra, but I'm not going to make enough copies that if you are irresponsible and lose it by Monday, that everyone's going to get a new copy. So make sure you bring your notes back and your homework back on Monday, and please be good for the sub. and do what you're supposed to do.